Okay. Does it look right?
Oh, sorry, I was muted. I can see your slides, but they're not maximized yet.
Yeah.
Okay.
Now it's okay. Let me. Is this right?
Yeah, there you go.
The problem I have our video image over the slides. Do you know why is that?
You can probably move that around. That's just showing the camera view, I assume.
Yeah.
Yeah, you can move that on your screen. That doesn't appear for us. We don't see yours anyway. We see our.
Yes. Yeah. It's just yeah, I can move it around.
And then students will ask questions through the chat, so you may want to keep an eye on the chat as well.
Yes, I think maybe every like 10, 15 minutes we can direct our attention to any question, or we, after I finish certain unit, we can move to if there is any question.
Cool.
How is the group formation going?
The groups are all together. They seem to be, most things seem to be going all right so far. The TAs have been assigned to the groups, and they're starting discussion on planning meetings and things like that.
That's good.
And then they all should be working on that first assignment, which is due this Sunday.
So how many groups there will be there?
There are 17 groups.
17. Yeah. So I think Thursday session would be at 10 o'clock.
No, it'll be the same time.
Same time, 1:50.
Yeah.
Okay. Here we have 58 students. Okay, I think we can start. Greg?
Yeah, go ahead. You're fine.
Right. Good afternoon, everybody. This would be our, I think, third lecture on domain engineering. It's a series of maybe lectures, and the focus today will be on feature modeling. And we will focus on some techniques and practices. And we'll end this lecture by talking a little bit about industrial tools and their contribution in the development of the feature modeling. This is a quick intro into my bio, and you can see this these slides on the canvas for your review. So there is no need to go over it here. Okay. As objectives for this lecture, we would like to really define some terms to warm you up, and then go into talking about features and feature modeling and feature diagrams and all that nice stuff. And we want to look at the drives for scoping decisions and how engineers make decisions when it comes to feature modeling, which is the first most important step in developing a product line process. We want to show you how to translate these feature diagrams into propositional formulas, and we also talk about dependencies and how feature models are developed in the sense of quality control. And as I mentioned, we will talk a little bit at the last part on some tools that are available to you that you might want to use in your assignment. Okay. So let's start with some definitions. Maybe you have heard in the previous lectures about these, so I'm not going to spend much time on this. But the whole issue about product line development is the issue of reusability. Software reusability is not a new concept. We've been hearing about it since the 60s. And there have been in every era a development of technology or methodologies to deal with software reusability. From the time of subroutines from the 60s to the time of using modules in the 70s. Then we got the object-oriented languages start coming in the 80s and start using objects, and then developed into components and frameworks in the 90s. And we see that as software product lines become more popular in the new century, and in 2000s upward, we see product lines are really gaining popularity, especially with the advent of cloud computing and the infrastructure development. It became clear that the demand of the industry of quick turnaround and high productivity of software that is on high demand way more than hardware. As a matter of fact, people noticed from the 80s that the software is always lagging when it comes to its intensity, its intelligence, its capabilities in comparison to hardware and infrastructure. Today, we do have a hardware that can take software for the next 20 years. If we freeze development in hardware and processing power, for 20 years will be still okay, because the software industry needs to catch up with this capability that we have today in the muscles and power of infrastructure, cloud computing, and etc. And here we talk about different techniques to do modeling for variability when we develop product lines. And today, maybe my most focus would be on the feature modeling using the feature diagram and trees. But there are other methods, as you see here, available. Maybe you need to read about them, like decision modeling and orthogonal variability modeling, like here. And then you have here variability modeling framework. This is popular also. And maybe the most popular is unified modeling language, that many companies still use it as a feature modeling technique. And there is a mixture sometimes between these tools or these methodologies between, let's say, feature modeling and UML. And this is your popular machine that will produce product lines. You have variabilities from one end and commonalities on the other end, and the decision-making engine and brain that will produce product line variations for industry and those who are interested in the product line development. So what is feature? To just keep it simple for you, remember one word. Feature is a concern. Concern to whom? To a stakeholder. If you just want to take out of this whole thing, this thing, it's enough. Because the word concern need to be qualified and the word stakeholders need to be qualified. And features come into different flavors. We call it attributes and abstracts. The software attributes or architectural attributes are features, and they could be functional and non-functional, and they could be concepts, abstracts, and they could be artifacts, and we will talk about this later. So feature is a logical unit, and in that sense, it could be functional, it could be non-functional. We use features in a product line because features are the key for us to identify a software line. It depends on what is included and what's not included, what is mandatory, what is non-mandatory, and so on. But at the end of the day, it's the issue of reusability. This is the key word. We want to use features and reuse features and create products by mixing and matching features to create products and be able to reuse our artifacts that cost us money to develop. And they were actually from scratch, developed to be reused. So we have these as like a machine that assemble cars or assemble products. The same thing, the same concept goes to software. So you have a product portfolio that you want to produce in your product line, and you have features that are already developed and or being developed, and then you have artifacts that been used in the previous projects, and you do your feature selection as it shows here. You have these products, and from these products you create your software line at the production level at the end of the cycle. Software product line domain is a tricky issue. You need to arrive to a well-defined and well-scoped domain. We mean by domain, as I'm going to explain in the coming slides, let me take an example. Let's say a company is in the business of developing, let's say, supply chain management software. And they are engaged in developing domains for their software. And they say, okay, we want to develop our software, let's say, for retail industry. Another maybe software line for our retail wholesale industry. Maybe another one for online shopping carts or retail experience, and so on. So in that regard, they would have defined the product line for each industry, and then they go into the feature and variability and commonality discussion to identify each product line, what it would include, and the flavors that they want to launch their software based on. This is in reality how it happens. Of course, the auto industry is also a big example that you find a company like Volvo. And by the way, don't forget that we have important lecture coming this Thursday, 1:15. We have a guest speaker from Volvo. He's going to talk about product line practice within Volvo company. And he will explain to you then how Volvo produce product line for their car series and how many thousands or hundreds of thousands of variations of software goes into these different options of their software that run their cars. And for the lay people, think that cars have little software to run it, but nowadays software is a key definer for what type of luxury, what type of options these cars would have. So domain is an area of knowledge, an area of concern to whom? To stakeholders. And we need to scope the domain in a way that is optimally designed to satisfy the business requirements. And there are economic decisions here to be made. There are issues related to concept to market time. There are issues need to be concerned with return on investment. There are issues to be concerned about in-house expertise. You may want to develop a product that people within your engineering team are not ready to develop. They don't have the proper skills, or you need to invest in hiring more skills, stuff like that. You need to also talk in the language of artifacts more than of the language of features. And we will see the relationship here, because an artifact could be multiple features or a combination of features that develop an artifact. Multiple artifacts will develop a product. And the purpose, as we said, is a reuse for this product. Okay, this just was a warm-up for you to remember the concepts, and let's indulge ourselves into some domain modeling and features modeling. As it's mentioned here, domain modeling would be to deal with to capture and document the commonalities and variabilities of the scope domain. So you have features, common features in an area, and you have variable features, and you have a domain. You need to match all these common and variable features and fit them into a specific well-defined domain to produce a product line that then you can do through variation modeling, produce a specific product. So we need to identify these features. It's very important to start with the feature model. The feature model would help us identify these commonalities and variabilities. And from that feature model, you can go and derive your products. I mentioned supply chain, for example, here as an example. And in supply chain, you have important modules like inventory management, point of sale. You have financial models that connect with the ledger of the company, the accounting ledgers, and you have so many things today. You have like the marketing things, you have the connection with the social media, you have the shopping cart, you have the ability to audit and edit, and all these little things that connect together. Then the company that's developing a product line for supply chain would be able to produce different product lines for different industries and use the feature model to do variations and customize their software to fit certain customer. Usually they would fit a group of customers, and then there will be very little tweak and implementation customization for each customer. Okay, let's here look at this issue of what is called feature UML, Unified Modeling Language. You have two pipelines here. One represents the domain engineering, as you know, in the general map of product line development. And you have the application track here or pipeline. And there is here connectors between them in different stages. Here you develop your domain requirements. If you will, this is equivalent to requirement phase in a single product, but we call it here domain requirement. As we told you, the domain has to do a lot with the stakeholders and the business requirement. And then you have here the domain analysis that we just mentioned something about it. And out of domain analysis, there will be feature diagram or feature models. And these feature models will feed into a product configuration. The product configuration is the kitchen, whereby the recipes are mixed to produce a product. But these are collaborating together. You have the domain being designed using UML models. I'm not saying every company is following this technique, but this is an example. And you have from the domain design, you end with UML model generation. You generate your models like we learned in a single software design. And here for the product line design, you use domain analysis, feature domain, and product configuration. If you want to compare these two cycles, this one here and this one here, this would be representing a product line, and this is more tuned towards generating a single product line. And then you go here to the implementation phase, and then here you start building actually your code, and you do the code generation to produce a specific product, and then you go to testing phase. But usually in agile process, it's not like sequential in this manner. You know that there will be a iterative cycle where testing is like in the forefront. For any code you develop, you test, and then you develop and test, and so on till you roll out your product. But just take this for illustration. But in reality, there is more complication and feedback loops to this process. Okay. In the domain analysis, there is lots of scoping. And in scoping, you go into these cycles: feature artifacts, artifacts products, products back to artifacts, artifacts back to features, and so on till you come back with the ultimate trade-off between these desired features that stakeholders will dictate or require and the product that you want to develop within specific constraints of cost, budget, time, and all so on. So this diagram depicts that these are products that you have. You go through the scoping to see which of these products are going to be part of your artifacts engine that will produce several artifacts. And we use this term artifact to describe way more than coding or debugging system or testing. It's everything that is contributing to the production of the software is called artifacts here, including a catalog, a manual, a user, everything, the testing that goes in, the documentations and the process of development and the feature models. All of these are artifacts because you will need them in your file to have a complete product delivered to the production field. Okay, here also, again, in scoping, we say when you have a domain, it's always preferable to have a small scope for your domain, because I know that the people who are looking to it from a business point of view, from a financial perspective, from ROI perspective, would want to have the domain scoping more areas. This is always a tendency that why not we include this customer, why not we include this feature, why not we include this application, because we will have wider market and then we're gonna realize more revenue. The temptation is there, but we are saying the smaller the scope, the more focused and the more clear are the features. And you have, the more you have similar product with a few variation, and you can then have much reuse of these variations. But the wider the scope of your domain, then the risk there of having so many features that are not homogeneous. There is no what's the right word? We will come to it soon. We want to make sure that these features sitting together in a single domain are not at odds. They are easy to develop. They are not difficult to test. They are easy to reuse, easy to plug in the I/O and the API, and all these issues related to the features not only contribute to a small scope, but they have to be decoupled properly and have a certain harmony across them so that they will not be in conflict. So this is a trade-off in the implementation process. If you notice here in this diagram, it says here concrete scoping a process equivalent to a combination of these activities. These activities here, not necessarily being used all, but a combination of them will create a concrete scoping process, like identifying the product, assess the product, optimize the product, and here identify the features, prioritize the features. As we said, you need to make sure that the most important features are included first. Then there will be subdomains and assess subdomains and identify assets, artifacts, let's say, and prioritize the assets. We're not saying that all steps here are being used by all companies, but a good flavor of these is being used either within the domain line or the product line production pipeline. Okay. Domain analysis, scoping, and common scoping process. Here we are trying to shed some light on the scoping, what goes into the scoping for the domain. First, you need to look at the product, the end product that you want to achieve. Which products do you want in your product line? So you have a consciousness of what products you anticipate. It's not like a guessing issue. You need to know at the end of the day what are the actual products that your customers will benefit from, and to make sure they are inclusive in your domain analysis. And if you have to drop a product, then there would be a strong justification to do so. So the market, the stakeholders will dictate the selection of your product. Then you come to the domain once the product is clear. And from the domain, you start thinking of subdomains. The product line, as we said, need to be as small as possible. So we might need to split the domain into subdomains. And the information that is going to be carried away with the domain, what are the reasonable domains for this product line in terms of knowledge and stability and etc. Then you go to the features. Features modeling comes after domain modeling. You know your domain now. You start focusing on the features. Which features will be used in the product line, and which product will have what kind of features. It's like back and forth. The product line requires certain features. We can make a combination of features to produce a product line. And we need to look at risk, because about managing projects is only about managing risks, and see if we have included certain features that are going to delay the production line, or we have chose a feature that is beyond our technology and engineering skills, and so on. Then we look at our assets. Which assets do you have in your product line, and the components that will be part of it, the documentation, and how this would help us in a future reusability posture, and how the company can benefit from re-implementing such domain and product line into future products. Okay, this is sufficient, because in other lectures there will be lots of talk about domain modeling in different perspectives. Let's talk about feature modeling, which is the focus of my lecture today. So let's first, before we get excited about feature modeling, focus a little bit about the word feature. So it's better to think of the word feature not as a product, not as a specific thing, but a concept. Let's say feature is a concept within a domain. Let's say we want to have a feature and go back to our supply chain software. We want to have a feature that enable us to provide audit at the end of the day for the point of sale, so that the general manager of all stores will know if there is any serious discrepancy in the closing that day. A feature. Let's call it security feature, call it audit feature, whatever it is. So at this level, the feature is still a concept because we haven't yet developed a software realization of it, or we didn't even discuss how this feature, if it's becoming compulsory, how it's going to affect other features, how it's going to affect the production line, how it's going to affect the reusability, how it's going to affect the coupling, decoupling, and so many issues. You don't just throw a feature into a product line and think it will not do anything for the other features. Can be seen as a high-level requirement, as I said. Some of them even are called feature abstract because they are not a specific product or a specific code or a specific implementation. So features represent commonalities and variabilities in product line, as we mentioned before, and it's a unit of communication. This is important. Maybe you may not appreciate this much, but really, if you are in the business of software development, you need support and backing. Support from those who finance the process, funding your development. You need support from the customer who is going to benefit from your product. You need support from all stakeholders. So the best way for you to communicate your ideas and build your case is to communicate through a feature model. You would develop the feature, show your stakeholders why this feature takes a central space among all other features, why it's important, how it will benefit the ROI, how it will be beneficial for reusability, and how it will contribute to the value of the whole product line. So it's a unit of communication, and actually a big part of it. When you develop a feature model in your assignment, I believe number 2, we asked you to develop a feature model. And the reason for that, it's going to be the accumulation of your requirements. You're going to squeeze everything you learned to develop a system into a feature model, and the feature model will be your communication vehicle within your team, within your group, and within the ecosystem of this course, and wherever, if you are in the industry, your feature model will be your tool to build your case. So specific sets of features determine a product variant. So you will be justifying your feature model by explaining about your product variants and how you are going to get product variants at optimal from this arrangement. So the feature configuration as input to product derivation. Exactly. So it's your input to produce something called product line, or if you will, product derivation. You want to derive the product from the feature model. So at the end of the story, as we start, we said feature is a concept in a domain. We say also feature is a kind of concern. Here you have a big concern. Let's say this is the stakeholder's concern. It covers a wider space. And here, when you build a feature or include a feature, it should take good portion, the larger, the better, of that global concern or total concern of the product line. So by building your features one after one, we hope that you optimally cover the concerns of the stakeholders. Okay, let's look at the feature-based configuration. We say it involves all of these and more. It involves checking for satisfiability of the feature models. You want to make sure that it covers, as I said in the previous slides, all the concerns, enforcing correct configurations. You have rules you have to follow. And we said coupling, decoupling, reusability, manufacturability. And I haven't heard really many people talk about manufacturability here. Of course, it's not a car we are developing, but in software area is developability, let's put it this way. Is it possible to do it within the time frame, within the skills in-house, and within our capacity? Enumerating valid configuration, you need to be able to show that within the product line, these are the configurations that are possible at the time. Propagating configuration decisions, then you need to be able to take these configuration decisions and show the workflow of how you're gonna then move from one stage to the other till you show the stakeholders the end product and how it looks. And merging distributed configurations, sometimes you need to merge some configurations into one or the opposite. Here are a list of good and bad practices in the feature selection. You want to select those features that are most popular with the customer, not with you, but the customer, stakeholders. Popular with developers. If developers don't like them, feel that they are troublesome and they are gonna cause issues, you have a problem. You need to get the buy-in from outside and inside. They have to be well implemented, not on the iffy side. You have to make sure they are error-free and thoroughly tested. And they conform with your selected architecture, style, and attributes, and distinct in their functionality, not just duplicate. As you see on the other side here, it's very bad to select a feature that some stakeholders think it's duplicate, it's redundant, it's not needed. We don't want you also to develop features that are duplicate of other features or optional, because if they are optional, then why you choose them? Or highly volatile, that means they might change over time depending on who is looking at. Okay, here in the feature modeling, and there will be more discussion about it, there are mandatory features, as you know, and optional features. And when we talk about propositional logic, we will be talking about the alternative features, and we're going to talk about optional features and explain about all these diagrams to be able to model them and use them in your tools to develop further your product line. This is a software product line is about feature modeling, because the hierarchy arrange set of features to represent all possible product line. It's like a combination game. You take your features, you take like a feature diagram like this and create different versions using different combinations, different features, and produce different product line. For example, here is a feature model for a mobile phone. And you know, Apple can come and say, okay, we want to produce, let's say, iPhone 12, and it will come into like 3 or 4 flavors. One of them will have 5G, the other will not have 5G. One of them will have great cameras, and the other professional one, and the other will be basic cameras, and so on. The screen, the processor, and the glass, the screen, all this. Maybe in the iPhone, there are maybe thousands and thousands of variations, but usually in defining a product, Apple is not going to come with 1,000 type of phone. They will confuse the hell of their customers. They need to be more focused, as like any other company. Even my example of supply chain management, it will be a failure company if they say, okay, we have 100 products. They don't do that. They usually have maybe 10, 15 products, and then when a customer comes, they say, okay, we realize that the most suitable product for you is a product 7, and we can take your requirements and customize a little bit and tweak a little bit product 7 to meet your exact business needs. So this is how it is done in the industry. So what I'm saying here in short, that even if you have developed a specific product line domain for certain industry, even if you have a product that is matching a specific customer, there is no way to escape customization for a specific product for a specific customer. But these customizations will become so much easier when you are following the methodologies of feature modeling and product line development. It's very easy for a company, if they have a customer that insists on certain requirements, to create for them or for the client a product within the time frame that is tolerable by this customer, to be able to take features and include features and then roll out and compile and send the software and test it and everything within the time frame that they can customize a software that would fit the use in production for this customer. Okay, here we say that the feature model is to express variability in terms of common and optional features. There are common features and there are optional features, like in the car business, and you will hear on Thursday a lot about that. The common features, we call it the base model. The optional features are the add-on, and it's very easy to add them or remove them as the client dictates. And this is part of the product line development cycle. Yeah, here, for example, in this diagram, let me just move this a little bit. In the diagram here, it shows you that you have variation point, which you can call it a product or artifacts. And you have here product models of what type of products you want. You feed them into, I call it the kitchen. Let me use this term always. This is the variation model and selection configuration model to produce product A, B, C, D as the market dictates and require. You will see this a lot in this field. Okay. Let me see, we may have another, this slides and give you a little break and then we can proceed and then look at, I encourage you, if you have any question or anything, you can just put it in the chat area and we will take care of it when we have a little break. Now we come to the modeling actually for the features, feature modeling and the feature diagram. The modeling process is nothing but to find a way that computer or automation tools accept a representation of a domain with features, and we can communicate these concerns I mentioned for the stakeholders into a standard methodology that computer or IDEs can communicate and produce for you the output product that you want, which is the variation products that you are looking for. It's all automated process. This is beyond the humans to get involved in, because you need to know that if you have a domain, let's give an example. If you have a domain that has, let's say, 10 variations, 10 features, sorry, a domain with 10 features, which is not really much. Mathematically speaking, the number of variations that this domain can produce in terms of product line is 2 to the power 10, and so on. But you know, in reality, features in any product line would not be less than maybe 20, 30. So you can see how things can get messy. You talk 2 to the power 20, 2 to the power 30, we are in trouble. I'm not saying that any company in its right sense is going to create a product lines, a subset of the number of possible features, because you don't use all possible features. And then you can see it's happening in the aeronautical industry, and the Air Force, in the auto industry, in the computer industry, in the mobile industry. The number of feature variations is huge. And you have to be selective, otherwise it will get out of hand. So the graphical notation to specify the feature model is shown here, and you will see it in many places. We have here the alternative structure. We call it the XOR. It's only one out of many. You choose one out of these features. Only one. You cannot choose two or three or four together. And the notation for it is the empty circle. And we call it XOR if you want to use Boolean logic. Here it's also explained more to you, the AND without anything. The alternative, which is the XOR, is open circle, and the OR is a dark circle, and they have mandatory dark and optional open, and so on. The OR feature here is sum out of many. You can choose one, two, or three, or nothing. So this is the Boolean logic that is going to be used in the feature diagram, and you will use it to feed into your automation tool. Here, for example, is an example for database. It shows an example feature diagram. It covers 65 features. And you have the tree here start with the node at the head. And even these gray colored boxes features are they have subtrees in them. And they can be further expanded to create more features. And you see here the relationship between the features. And it has embedded data management. And this is just for a database showing you how you can create a feature diagram to represent a feature model that you can use later for developing a variation and configuration engine. Okay, I think I'll have, maybe we can cover this and go for a short break. I don't want to keep the session long on you, and then we look if you have any concerns or questions. The formalization of the feature model comes in a propositional logic. We call it propositional logic. And the feature diagram can be directly mapped to this propositional formulas that we can later program and feed into our computer. So the mandatory feature, as you see, it's related to this between a child and parent. And we use double arrows that shows this is mandatory. When it is optional, we don't use double arrow. It says that if the child is optional to the parent, I mean, the parent doesn't need the child, that's sad, but this is the optional representation of that. And then you donate it by saying mandatory, BF, and here you say optional BF. This is the simplest propositional logic that you can see. Here we can also do the formalization for propositional logic for the disjunction, which is the XOR, the alternative. So there are different names for this formula, but I advise you really to pay attention to these formulas, because all what you need to know is this and this, and then life will be easy. You have to know its alternative first, because it's the open circle, if you remember. And here you put the parent, and here are the possible list of a childs from 1 to n. And you say it's equal. This is a child, or this is a child, or this is a child, or this is a child, but they are mandatory to the parent in the condition. This is ANDed with a condition of Boolean logic that says it can be disjunctioned in the condition that no two children can be selected. Only one was it, one and only one. This is why you have this negation of the ANDed feature, child feature. So simply you understand this as it's an XOR relationship in the Boolean algebra. And it shows a relationship between a parent and n number of childs. And this could be several terms. It depends on how many i's and how many j's you have. Same thing goes here. The relationship for or, which is the bold picture, or is different in a sense that it is mandatory, as we said in the previous one, but you don't have this part because in the or there is a freedom to select more than one. So propositional logic enables us to use automated tools, as I mentioned, to test interesting properties. If somebody wonder why we need all this mess, it's just to enable us to represent and encode these relationships in a way that computer can do the analysis and produce the variation and the configuration for us. If you remember, I said the configuration process of product line is fully automated, and that's the big gain out of the whole process. We don't want to do things by hand. And this is what will happen in your assignment if you want to develop a feature model and then use propositional logic and then feed it into the tool to go into the configuration stage. Okay, I will give maybe 10 to 15 minutes break. Let's be specific. I will be back at 2:15. But before that, if somebody has any question or comment, I'd like to address that before we go to the, let me see the chat. I have two things in the chat here. We can see the PowerPoint not in presentation mode. Is there any problem with the PowerPoint? Okay, that's maybe before we started. Okay, does the OR with mandatory nodes mean that you have to pick either the B plus minus 3 or the list of both, but not none? Maybe I see you, I know the language here. If you talk about the OR, let me go back to this here. Which one is or? Let me move this little bit here. For example, here, if you look to the relation between the parents and the child, you have 4 of them that are engaged in an OR relation, which is, they are all mandatory, by the way. It says here in the OR relation, you can pick this alone, no problem. Or you can pick this and this. Or you can pick all of them. This is OR relation. In logic, the logic OR to be correct, you need only one term to be correct, or a combination, or all. So regardless, any one of them is selected, which is mean correct. That would produce the OR relation as you wish. Okay, it is specific to that slide. Could you go back to the example where there were black nodes on the child? I don't know which one you mean, but let me see. I think you wanted this one here. Of course, when you introduced the OR, you said it could be none as well. Yes, maybe I have said that. That's wrong. In the OR relation, if all of them are not selected, this is not true. And that's not the intention, really. At least one should be selected. Thank you. That gives me really comfort that you guys are listening and following closely to what I'm saying. You're not going to let it go without scrutiny. Thanks a lot. Okay, we will be back in, oh my God, it's already 2:05. Let's say in 2:18, I'll be back to you, and we will resume. I want you to refresh yourself so we can go into more serious stuff in the second half of the lecture. Thank you very much. Okay, I think we will be back. Hope everybody is back. All right, let me. This formalization of propositional logic to enable us to map what we have in terms of feature tree or feature diagram into propositional logic. It will take us like 2 or 3 steps to put the formality on it. But I want to make sure all of you follow this. It's not a big deal. You start with the root, which is the head of the diagram. And you say, this is a graph library example. We see here a relation that is mandatory. So we start here. And you see these and. This is the connectors that connect the whole diagram together. And it says mandatory because it's a solid dot. And it says a graph library, which is the root, the parent, and the child, which is the edge type. Same manner, this is optional, this is optional, this is optional. You see this is optional, optional, optional. Same thing, the parent, the child, the parent, the child. And then we come down to the second level of the tree. And we also put the head of the relation here, alternative. We come to this one here, alternative. It's an edge type. This becomes a parent now. And these are the children. And the relation here is alternative XOR. So we put alternative because later we're going to substitute this with the formula that you saw. And we mention here first the parent and here into curly parentheses the children, directed and undirected. Here, I think there is a typo mistake, not from me, from the book. It says it's an OR relation, search, BFS, DFS. It is not. It is supposed to be like the one above it, alternative. I put it here, alternative, search, DFS, BFS. So take note of that. And here, we have an OR relation of 4 children. So you see the root, the parent, and the 4 children to follow. Here at the third level, you see an alternative relation for MST, and then 2 children to follow, and so on. Now, I want you to look at how we transform this into the second level. Why it's not moving? Let me change this. Okay. Now we take the same thing that we did here into the, let me change this to laser. This is what we saw in the previous slide, and we want to now convert it to a propositional logic per the formula that we saw before. And this is what's mandatory. we convert it to mandatory relation between parents and the child. Here is also mandatory. Here is optional relation, optional relation, optional relation. And when it comes to alternative, we put the parents and the children, the relation, and then we saw the mandatory. And here you see the formula, exactly like the formula that we mentioned before. It's just a translation of the formula. This one here, I said that has a problem. I put it here correctly down. It's supposed to be alternative relation, not an or. This one here. And the rest are direct translation to what you have seen before. Okay. There is a situation I want you to be aware when you have more than 2 children and then XOR or the alternative relation, you have to do the enumeration of each child 2 at a time. Look at this here. When we had 2 children, we used to put just one statement here, which is the negated of and, complement of and. But when you have 3 variables or 3, let's say, features, children, you have to do the combination of each, like this with this, this with this, and this with this. So 3 of them will create 3 combinations. If we have 4 of them, it will create 16 combinations. We're not going to challenge you with 4, but if you are, you see 3 of them, just make sure that it's not going to be just you test 2. You have to test all the combinations. There should not be any picking of 2 at the same time in the XOR relation, because it's only one and only one. Okay, I hope this is clear. Here we are talking about the proposition logic for the following slide, but it's easier for you to follow by I just gonna comment on the diagram. These are variations of the feature diagram. And there are a lot of variations in the market. You will get used to it as you go through it. Don't sweat about it. Here, for example, DirectX implies that you are using Windows. So you create this arrow to explain to your readers or your next engineer that if you choose DirectX, then you have to go to Windows. It implies. So sometimes there are constraints across features that you need to show at the feature diagram. For example, here the legend says that if it is shadowed, then it's not actual feature that correspond to a specific artifacts, but it is an abstract. API is an abstract. Operating system is an abstract. You cannot tell a designer, I need a theme that is operating system. It's just a designation that would help you understand that what comes as a child here is an operating system. But then the ones that are not in shade are actual concrete thing. We are talking about something specific. And the rest, you know the rest. Here, for example, there is another variation that you could substitute. These are 2 equivalent feature diagrams, because Y here is an abstract, you can then eliminate it, and X is an abstract, then you can eliminate it, then you can say A has a relation, X or relation with B and C. So this is the type of thing that you will see. Here, for example, you don't have to have all children under same relationship. For example, I and J have an XOR relation with D, but not K. So there's another flavor of feature diagram that comes as such. Okay, this will conclude talking about the feature modeling here. I'd like to spend some time now talking about feature modeling automation. As I know that on Thursday, you're gonna hear a lot about the auto industry. I don't want to focus much time on this particular part, but we will go through it a little bit faster. We will talk about using this in feature modeling for auto industry. For example, look at this example with the steps. And this is the following, show how to create master model and use it to derive different products. What I mean by master model, let's say Volvo has an XC60 model that they produce, and this is called master model. And after that, they want to create a product line out of it and derivations. This is what's in general, the process that they go through it. Step one, incorporate all input stemming from functional, non-functional, domain guide, and feature models. So we are saying that to develop the model, you need to look for your features, which will be consistent of functional, non-functionals, and domain guidelines. Iterate across this feature model until we have a correct level of feature level leading to the, let me see this, leading to an atomic tangible feature that can be tested. What it says, in feature model diagram, you drill down your features, as you say, level 1, level 2, level 3. But you have to be careful. You keep doing this process till you reach a level where it is testable. This is our benchmark indication. If you reach a feature that is testable and implementable and simple enough to be understood by the next stages, then you should not drill down further. Because having deeper nested models is going to create a complex feature model that is difficult to manage. Include the feature model with hardware, software, and mechanical model options to realize the feature test, because you are not dealing only with software here, because different features would mean different, even hardware and software and so on. It's very messy. Map the feature constraints relationship to form master feature model. Remember the curve that I showed you in the previous slide that talks about constraints or conditions, that if you select this, you have to select that. If you choose this, then you have to drop that, and so on. And here at the end, you start the mapping process for propositional logic, as we said, from your feature model. This is unfortunately not a clear diagram. That's the best I could find. But it shows the feature diagram of a master model for automobile. And it shows here is hardware, software, assets, and so on. And it drills down. This feature model shows 3 levels. Usually in reality, there will be maybe 4, 5, or 6 levels of complexity. And the features will be in hundreds rather than in tens. So this is just to give you a flavor of it. In step 5, we review the product variations for different vehicle segments. Now you have the feature model and you have the propositional logic, and you are able to do the configuration management. And configuration management would require the variation model, and then you start picking and choosing to create your product line. Perform model checks to ensure that there is no risk in achieving the features. It's sort of testing your variation model or testing your configuration model to make sure that you haven't made any mistake. This is simplistic variation matrix, variant matrix. It shows some features just for illustration. And here, for example, where their product geared to the US or geared to Europe or geared to Far East would be selecting of certain features that are required either by regulators or law or customer taste and so on. This is showing you using feature ID. I'm not sure which company is using. Most of them would have developed their own tools to do the feature modeling and select the features and the variations. But it shows here clearly how the feature model looks like, for example, for the US, and how this looks for Europe. You will notice here the selection of certain features is absent in one and available in the other, and so on. It's just like a click and choose till you come to the model that you want. And remember, this could get complex. This is why you need automated tool to automate the process. Okay, let me talk a little bit about some of the tools that are popular and people use either in academia or industry. I start with the pure variants, or sometimes called the pure systems. Pure variant is the good thing about it. It's a well-documented tool. It is available in academia, and I think it's been made available for Chalmers students as we speak. I think Greg made some contacts, and we might have this tool available to you. It's a very powerful tool and user-friendly. I scanned through the user manual, and I have prepared some stuff here to tell you about it in little bit detail. But it's not my intention here to introduce the tool, but just to tell you its capabilities. Here are different domains. The problem domain is represented using hierarchical feature models. So as you know, there is a problem domain and there is application domain. And in the problem domain, you have the domain modeling and you have the domain solution. So we have a problem and solution. In this tool, it has a very powerful hierarchical feature models. And if you are able to use it or use a feature ID to develop your hierarchical feature model for the assignment, this would be great. The solution domain also has a concrete design implementation software. It's a family of software implemented for family models. So this is the solution domain. It has the concrete design and implementation. And then we have the application problem domain. You have the variant description model, VDM. Variant description model, if you will, I said about configuration model. This is equivalent to that. It selects feature sets and represents single problem. So you can, from this model, create your products in a product line. You have also the variant result model describes a single concrete solution drawn from solution family. It will allow you to come down to pinpoint a specific product and produce the feature diagram for that specific product. This is some graphical representation of the modules inside the pure variants. And this is the problem domain, solution domain. Then you have the application problem domain and application solution domain. In this one, the focus is on feature model, as I said. In this one, it will be the focus on variable, and you can use UML and sysml models to create a solution domain. And here in your variation and configuration, you have the variation, as I said, the VDM, the variant description model. And here the same, it will allow you to do the configuration automatically and produce the products. It's the same representation here, but in more elegant details. It shows you each modules and how to it's deployed in this tool. This is, for example, showing you the feature model in the domain analysis area, the problem domain. And here you are allowed to select features and define the constraints and all these things. And then you take them to the configuration model, variation development model VDM to create configuration 1, configuration 2, configuration 10, it doesn't matter. But this is how it is done to create your configurations. This is showing also a feature model that's been created by Pure Variants. It's a weather station, and you can even take this and implement it yourself and draw this diagram and see for yourself how it does it. We are not here gonna go into details to explain this for the benefit of time. This is also another snapshot of the tool. It shows you this is the user platform here. The layout of the variant management perspective. When you select a variant project, let's say you open a project here, the upper left side of the Eclipse window will show that a project is opened, and create initial standard project using context menu, and view new variant project. And then you will have, once this is established, then you can start developing your feature model as it's seen here. Here you start developing your feature model. In the following slide, we tell you what each window here means, and the properties view in the lower middle here of the Eclipse window shows properties of the current selected feature. So when you select a feature, you will get more information about it in this window. The table tab of the feature model editor shown in the lower left part here. Here you can do editing for your feature and so on. So anything, if you just, when you have the license available to you, you can use the manual and go through some training videos, and you will be fine with this. There are actually more tools available to you or to the industry, like Feature ID is more in the academia. We have Capella, and they work together, by the way. You can sometimes use both of them. You have Gears. I'm going to mention more about Gears in the last lecture about the industrial case. And I mentioned already Pure Variants as a tool also available to you. Feature ID also provide you domain analysis like Pure Variant. It uses feature models specifying valid combinations of features. It provides you with the tool for requirement analysis and enable you to do configuration support and help you with developing the feature model. You have domain implementation, and you have also product derivation, like in Pure Variant, you have a derivation model. Here you have also derivation model for several generation tools. And all of them, by the way, Feature ID and Pure Variant and Gears allow you to interface with other products like Eclipse and other tools, UML tools, to develop your project, because they understand different customers have different needs for APIs. Here, there is a feature traceability to trace features in feature model, configuration, and code. Feature traceability is important, and I believe in Gregory will talk about traceability in product line in some lectures. It helps you in quality assurance to do certain quality assurance things as well. The Feature ID also supports all phases of feature-oriented software development. So if you are using feature-oriented software, it will support you with Java, with any other language. It will work pretty good. But I don't know. I heard that Pure Variants might be more friendly than Feature ID. I am not sure. I haven't used both to judge. But both of them are capable and have all the modules that you might need to use, and the documentation. Let me move to, this is a snapshot also for the Feature ID tool. And it shows here in one window, number one, that the feature model editor It allows you to draw the feature model and enable you to edit it. Between 2 and 4, you have here the configuration editors. You can edit and change, like here showing all features in 2. It shows you the features in hierarchical mode. And in 3, it will show you also the children, direct children of the parents and the relation between them and the constraints. And here it allows you in 4 to finalize your configuration and produce your configuration model or feature model. Okay, this would take me into the last 20 minutes. I have decided to include these principles of feature modeling. These actually were part of a published paper that a co-author was Dr. Thorsten Berger from Chalmers and with other colleagues. They have published a paper talks about principles of feature modeling, and I thought it's worth to introduce it to you and shed a light on these principles. They would help you in feature modeling. So we said before about feature modeling, it's a communication tool, help you understand the system, communicate with the stakeholders, and support scoping and planning, development, help you in variant derivation, configuration, testing, and maintenance activity. So it's a very critical step and process in the whole development process of product line. So in this research, the authors have cited 34 principles covering 8 different phases of feature modeling. These principles provide practical, context-specific, and also advice on how to perform feature modeling. So what we are saying here, that these principles, they go area by area and guide you to do's and don'ts. These are like recommendation. If you will, you can take it as like a best practice type of analysis for feature modeling. So let's go through them one by one, area by area. Here we have in the area of planning and preparation. For example, in the first point, it says identify relevant stakeholders. This is important. They see from their experience that engaging in early stage stakeholders and the right stakeholders, not the wrong ones, would help you a lot at the architectural part stage of the project, and help you in gathering the requirements and understanding the concerns, as I mentioned before, as features are concerns, the concerns of whom are the stakeholders. So the second one, in mature or heterogeneous domain, unify the domain terminology. Because there are so maybe in your team or in your stakeholders, there is an issue of terminology that people may have miscommunicate issues related to requirement, related to features. So you have to be careful to make a homogeneous strategy to define things and communicate them in a proper and clear terminology. Define the purpose of the feature model. You have to have a clear conscience of why you are developing such a feature model. What is your purpose? Some companies or some teams or projects have different priorities in developing the feature model. Some of them are developing it for more for communication side, business side. Others develop it for more technical and know how to develop side. This is why it says here, support the actual product line development or support the management of the product line. So they are not in conflict anyway, but the emphasis here, the issue of that you have to define your purpose of developing a feature model clearly, so you would maximize your benefit. Here also still we are in the planning and preparation. Point number 4, it says define criteria for feature to sub-feature the decomposition. When do you stop? I mentioned that. You go into your feature diagram level by level. So where is the end? Is the end gonna be a line code? No. You're gonna come to a feature that is clearly defined, clearly testable, clearly deliverable, and easy to execute, or you have it there, it's reusable. Then at that point, you will say no more sub-features. So there are some abstracts in your features. You don't need to do decomposition for them because they are concepts and you don't need to decompose the concept. A planned feature modeling as an iterative process. Feature modeling should be iterative and alternate between domain scope and modeling scope. What we mean by iterative, you have to have feedback loops. When you finish something, you take it back to the features. You took the features, take it back to the model, and so on till you come with something that really satisfies everybody. So make sure of this cycle. We talk about agile process, where it's not like one line and you finish. It's not an assembly line and you finish. It's going to be back and forth till you get what you want. Okay, the last point here in this group, keep the number of modelers low. Industrial practice shows that the number of stakeholders performing the modeling should be low. They are talking here about you. Let's say you and your group. You don't need all your group to be engaged in the modeling process because it's such a delicate thing and requires certain focus and attention to some details. If you involve more people, there will be some conflicts and people looking at different things, and it will be a chaos to have more people involved in the modeling phase. They can be involved in the verification, they can be involved in the testing, they can be involved in the iterative process, back and forth, give you feedback. But those, the architects, the brains that develop the feature model should be limited in number. And here they suggested really, I think, one person or maximum two. Yeah. So especially in the modeling process itself. Okay. And here in the second group, they are talking about model organization. They talk about the organization of the team and the developers. The depth of feature model hierarchy should not exceed 8 levels. Still, again, we were talking about decomposition before, till you reach to a feature that is implementable and simple and understandable. Here they are talking about the depth of the diagram. Actually, 6th level is very deep. I mean, the company must have tremendous capability and capacity in its engineering capabilities and automation to handle feature models of 6 levels because of the complexity of it, because of the vulnerability to errors and the constraints, the interaction between features. It's going to be very complex if you reach to the 6th level. It depends also on the number of features. If it has very little features and deep levels, it's okay. But if it has many features and also deep level, then you have problem. Here also, they talk about features at the higher level, and the hierarchy should be more abstracts. It's like they are referring to hierarchical decomposition. When we say hierarchical decomposition, we mean that features at a higher level should have higher abstracts, and then you decompose them to a less abstract concept. Like, for example, you say operating system. It's a feature abstract. It's high level. Then you come down, you say, oh, we mean Windows. Then under Windows, what type of Windows? What version of Windows? What features of Windows? And so on. So this is what they mean, that higher levels should have higher abstract. Here they say split large models. Several sources state that large feature models with thousands of features should be decomposed into smaller features. So what is That means, let's say you are involved in feature modeling and it's getting out of hand because your stakeholders keep adding features and wanting this and that, and the constraints are growing, and the deeper the layers are growing. And at this point, you have to make a major decision to split your model into two different variation models, into two different product lines. We said in domain analysis early enough that it should be simple. You should not go into complex domains that will cause you lots of headache, especially in testing. Okay. Also, still in model organization says avoid complex cross-tree constraints. You remember these constraints that cause you coupling. If you have constraints, one feature dictate on another feature what it does, or what one feature nullify another feature, or one feature make another feature redundant, or one feature is a precondition for another feature. If you want to put this feature, you have to include other features, and so on. All these cross-tree constraints, it says avoid them. Try to avoid them as much as you can. How you avoid them? By simplifying and further decompose your features into smaller features. If you learn about in computer architecture modeling, in modularity, and in dealing with coupling and decoupling of processes, we always say we prefer small services. This is why microservices as an architecture is desirable, because it allows you to decouple the processes. Here we talk about decoupling features because of cross-tree constraints. The last one here is maximize cohesion and minimize coupling with feature groups. This is true, it's related to the upper one, but here maximize cohesion means that features are really of the same class. Features are of the same tribe. Features are interrelated in a sense that they are not strange to each other. They can coexist within one system. You don't want to have conflicting features. You don't want to have less cohesion. And we will talk later in modularity about cohesion and what it means, because cohesion means harmony, means systematic coexistence, co-living. And this is what cohesion, and this is why your features should not be weird and strange to each other. They should really relate to each other, and in a logical sense and in the implementation sense. Okay. The third group is in the modeling. We still talk about feature modeling principles. In the area of modeling, first recommendation is use workshops to extract domain knowledge. What they mean here in the requirement elicitation, or when you sit and collect your requirements on harmonize the demands of your stakeholders, you hold these workshops, you hold this FICA, and sit with the people and use your knowledge and initiate feature modeling. Try to start brainstorming in a way that it would bring the modeling concept to clarity and to agreement, and then you move. Because if you do it so fast and still you don't have on board some stakeholders, or there is ambiguity somewhere, you know what will happen next. Focus first on identifying features that distinguish variants. You don't want similar features or duplicate features or features that doesn't make any sense. They are not going to add any value when it comes to product distinction. You know, the reason we add features to the feature model is to enable us to create variants. If your feature are not going to add any variants to the model, to the feature model, then what's the point? Why we are adding it? We are adding features to enable us to create more product lines. So if they are not going to help us get us these product lines and make them distinctive from other product lines, from other products, then you have to be careful of adding features. Here talks about applying bottom-up modeling to identify difference between artifacts is really less important. And it talks about your analysis should be bottom-up or up bottom. We will see it here, and the other one, apply top-down modeling to identify difference in the domain. For top-down analysis, it says top-down is successful with domain experts, more abstract features. So it depends on the expertise of the analysis, people who do the analysis. They say top-down analysis is for those who have more expertise. And it says the features that emerge from the top-down analysis typically represent commonalities or abstract features that help with feature model structuring. So because we said when you move from the top, you have more abstract, more commonalities, less variation. And as you go down, you will become more specific and more detailed. Therefore, you see more variation, less abstraction. So this is another methodology of looking at it when you apply your modeling from top down or bottom up. It depends on the philosophy, but here they say they notice that those who have more experience can do the top down. Less experience do the bottom up. And here he says use combination of bottom up and top down, and every methodology will give you different features and advantages and allow you to see things that you don't see it in the other one, and so on. Here, last one, a feature typically represents a distinctive functional abstract, while some work use feature models to represent non-functional properties. We say that the feature could be functional, non-functional, or abstract. And here it says a feature typically represent distinctive functional abstract. So we need to look at the performance requirement and the physical properties, and look at non-functional also in a way that it would help us create features that represent these requirements by stakeholders. And we should not be dragged by those who consider features only representing functional abstraction or functional requirements. We should always make sure that we have captured all the requirements, including non-functional ones and abstraction ones, into the model. Okay, here it talks about a last group is dependencies. If the models are configured by company experts, avoid feature dependency modeling. The same thing goes. This talks about coupling, decoupling. When you do the feature dependencies, it will be a problem because it creates coupling, and dependencies is not desirable because of the implementation side. When you finish your development of product line and go to create single products, you're going to face a problem in testability, reusability, and this coupling will cause you a big headache because of the interdependency across the modules would increase the work on you, and it will not be agile as you want it to be. If the main users of feature model are end users, perform feature dependency modeling. Okay, it's the same thing here about feature dependency modeling. We said if your end users are, if the main users of the feature model are end users, then it says perform feature dependency modeling, because the end user, in this sense, not necessarily the customer. The end user could be the one who is going to develop the product line. And they need to deal with feature dependencies. In the modeling, you have to try to avoid it as much as you can to make their job easy. This will take me to the last slide. As we mentioned, in this lecture, it's very important to develop feature modeling with a good understanding, taking attention to the principles that we mentioned at the end of this lecture, taking care of the stakeholders, understand the purpose of developing the feature model, why you are doing it. And there are two major purposes we mentioned. One is to communicate and get the buy-in for the product line. And the second important usage of the feature model is to guide the development process under the variation. We mentioned about how you select your features, how you model it, how you transport it to the propositional logic algebra, so that you can submit it to these tools. And I need to look to see if somebody here added any chat. I don't see much. If you have any question, please. If you don't have it now, you can send it by email to us, and we'll be more than happy to engage you. Let us know if you have any question. And I hope this lecture will open for you some ideas and help you with your assignment and understanding the material. And thank you very much for your patience. I will wait maybe a minute or two to see if you have any question. Okay, if no questions, then we'll let you go. Thank you very much for your patience, and we'll see you in the next lecture. Thank you very much. Okay, bye.